I recently created a 10-minute video about getting started with Firebase on iOS. Let's see how quickly we can get this done in real life. So first of all, let's go ahead and go to the Firebase console and add a new Firebase project. So add new project. Let's call it Make It So Semi-Live Live, and then hit continue. Select my default account for analytics, and then wait a couple of seconds while this is provisioning my project in the background. So while we're waiting for it, we can go back into Xcode and fetch our bundle name. So the bundle identifier is an important information that we need in our Firebase project in the console. So the project has been provisioned. Now let's go ahead and create a new iOS application here. So what we need to do is we need to provide the bundle name. That's what I just picked up from Xcode. Then we can give it a nickname. Make it so semi-live. And then register the application. So in the next step, we will get this configuration file, which I'm going to download. And then we can drag this right into Xcode. So the best place to put it is right beneath your info.plist. And if we look into the file, you will see that it's got the bundle name right here. And here is the client ID for my application. So these are pieces of information that Firebase will use to connect your application at startup to the underlying Firebase project that we just created. Cool. So let's go to the next step. And then what we need to do next is to install the Firebase SDK using CocoaPods. So let me quickly jump into my console right here and then change directory into where this project is stored. So semi-live, make it so. All right. And let me create a new pod file using pod init. And then open Visual Studio Code, which is a little bit of overkill. I'll give you that, to add my pod specification. So for starters, we don't need very many Firebase pods. So for the moment, let's use auth, always a good thing, because we will need it. And then let's also use analytics, and that's good for now. Going back to the command line and do pod install to download the pods, generate the Xcode workspace, and then it tells us to close the project in Xcode and then reopen it, or rather reopen the workspace. So there we go. Here is our project. Here is our pod project. Here are the pods that we added. And now let's go into our app delegate and make sure that we initialize Firebase at startup. So first of all, let me import Firebase, and then do Firebase app.configure. This will basically read our configuration file and then connect to Firebase. So to see if things worked all right, I'm going to launch the application on the simulator, and then we're going to go back into the console to take a look if everything worked nicely. So the application is starting up, taking a couple of seconds here, and you can see down here in the debug window that, analytics has started up. So this is looking good already. So let's go back to the Firebase console, go to the next step where it tells us to do what I just did. And then let's see if this works. Well, sometimes it takes longer than a couple of seconds. So yeah, there we go. So it has detected that we have started the application once, and it tells us the SDK setup has been completed. Great. So going back to the console, and now let's go back into Xcode and think about how we are going to map our data model to Firestore. So let's go back into Xcode, and I'm going to pull up our task class here. And then let me just rearrange my windows a little bit so we can see the Firebase console and Xcode side by side, and then do a little bit of playing around. So our tasks all have 3 attributes: an ID, a title, and a Boolean completed to track whether a task is completed or not. So let's go into the Firebase console and then create a Firestore database. Let's start in test mode. By the way, please make sure to use proper security rules when creating Firestore databases. This is not secure. It's good enough to get started, but once you have real data in there, you should use proper production mode rules. So this is good for now, but definitely change it later. All right, so it's provisioning Cloud Firestore for us. And then in a moment, we will see the database browser. And what we're going to do is we're going to prototype a task in the database just to see how it might look like. So there we go. This is the database browser. And we're probably going to store our data in a collection called tasks. And then we can define a test document for a test task. So we've got the title here. So let's also create a field for the title. It's going to be a string. And then let's again use one of our elements from the test data collection. So implement the UI. Let's create another field for the completed attribute up here. So we call it completed. And then this is going to be a Boolean. Let's say it's true. That's great. And then we've got another attribute here. It's called the ID. But this one we're not going to add as an attribute to this document because we're later going to use a specific property wrapper to map the document ID that is automatically assigned to the task back into this struct. And you'll see how in a couple of minutes. So first, let's save this. Here is our collection. And here is our document. Here is the title, and here is the completed state. And we can go in and make changes. and any change will result in the path to this change being highlighted for a brief moment. So I think this is a good way to model our data. So let's go ahead and actually do this in our application. So let's go back to Xcode. And in order to work with Firestore, we need to add 2 more dependencies to our pod file here. So the first one being Firestore itself. So Firebase /Firestore. And then there is another one that we want to use. It's called Firebase Firestore Swift. And this one is going to help us a lot because it contains codable support. And by using codable support, we will, save a lot of code that we would have to write ourselves to map data back and forth between our struct and the documents in Firestore. So with the codable support, all of that is being handled almost transparently for us, which is really, really great. So let me go to the console and run pod install really quick so that we get our dependencies installed. And so this looks good. So while we are waiting for it to finish, we can go back into Xcode. And then we're going to implement the repository. So if you recall from last time, this is the architecture for our application. So it's a view model architecture. And we're using a repository down here to communicate between the view model and the storage, which in our case is Firestore. So in the next step, I'm going to implement the task repository. So let me create a new group for that. So a new group, repositories, because I might have more than just one later in the application. So let's put it here. And then create a new file, a new class. And let's call it task repository. All right. So obviously, because we're going to use Firestore, we need to import Firestore, but we might need to run the compiler first so it can parse all the symbols. So let's wait a couple of moments while it's doing that. Okay, so it has now compiled, and let's see if we can import Firestore. Firebase Firestore, that's great. And then also let's go ahead and import Firebase Firestore Firestore Swift. There we go. Cool. So it's a class called task repository, and it will implement observable object so that we can listen to any updates that are going to be published by the publishers that we're going to build in a moment. So first of all, let us get hold of Firestore itself and store it in a property called db. So Firestore equals Firestore. And then there is going to be @published var tasks, which is our collection of tasks. Right. So what we want to do is we want to listen to the collection tasks in our Firestore instance here. So we want to listen to this collection back here. And actually, this is not tasks, but task, right? So let's implement a method. Let's call it load data. And in this method, let's set up a listener, a snapshot listener that listens to this collection. So let's go ahead, use db.collection, and then let's listen to the tasks collection, add a snapshot listener, and then we get a query snapshot back, and we might receive an error. And then let's see, if the query snapshot is not nil, we can go ahead and then take the query snapshot, get all the documents that it has fetched, and then iterate over all the documents. And I'm going to use a compact map. And then we're going to get a document, and the next step, usually what you'd have to do is you'd have to look into the document, which hosts all the fields that are in the document, and then marshal all those properties, all those fields on the document back into your data structure that you're going to use in the application. And thanks to Codable support, we won't have to do any of that, but we can go straight ahead and say document.data, and then as, and then we will specify task.self to indicate that we want the Codable support to try to map the document into a task. So the compiler complains and says, well, you know, task doesn't conform to decodable. So let's have a quick look why it's complaining. And the reason is we didn't tell it that this actually is codable. So codable, let's do that. So a struct is codable if all the pieces that are in it are codable as well, and all the primitive data types in Swift are already codable. So bool is codable, string is codable, so we can just claim, all right, the entire struct is codable, and that's fine. So the compiler should be happy now. Except for, obviously, this might throw, so we need to do something about that. So let's very simply do a try question mark. And then what will happen is, as we iterate using compact map, we transform all the documents into task elements, task structs, basically. We can assign those to the tasks collection. Just like this. So it's complaining about, not being able to assign this. Let's see. This should work. Oh yeah, I know why it's not working, because we still have a question mark there. So and there we go. There is another typo. So now we should be fine. Cool. We've got our repository. And the next step is to actually use the repository in our view model. So let's go down into our task list view model and then go ahead and use our repository there. So task repository equals task repository, and we'll just instantiate it and make sure it's published so we can listen to the tasks collection that's in there. So in the next step, we'll replace this piece of code. So currently, this piece of code goes into our test data collection and converts all the data in there into task cell view models. And we're going to do the same, but instead of using our test data, we're going to use the data that we're fetching and listening to using our task repository. So let's do that. So let's get the task repository and then take our tasks in there and then go ahead and map them. And we get a task. And then what we want to do is we want to turn this task into a task cell view model. So we can basically just take this piece of code here, move it up there, delete those 2 lines of code. And then let me format this a little bit. And we want to assign this. All right, let me tell the compiler I'm serious about it. Task cell view model doesn't take a task. This is interesting. Oh, yeah. So instead of a task, we still get a collection of tasks here. So tasks in, and then tasks. So you see this is a collection of tasks, and now we can go and map those and transform them into the task view models. All right, so we get a task in, and then we want to convert it into a task cell view model. And this takes a task, and now it is a task. Great, so result is unused for sure, because we still need to assign it to a collection on self, and the collection that we want to assign it to is task cell view models. Task cell view models. And then make sure to store the cancelable. Like this. All right, so let's run the application and see what happens. So nothing happens. No data is visible. And let's see what might be the problem. So first of all, let's see if we do have data in here. So we do have data in the database, so it should technically go and fetch the data. So let's go ahead and see what might be the problem. So I have an idea what might be wrong. So let's go ahead and add a little bit of debugging code here. So first of all, let's actually do some sort of error handling here. And then when we get an error, we will print it, and then return nil. Okay, well, it succeeded. Let's set a breakpoint here, run the application again. Oh, yeah, this won't work because it's unreachable. So let's do it differently. Let x equals, and then return x. Okay, like this. And run the application. All right. So it didn't hit the breakpoint. All right, so we actually don't call this method yet. So let's quickly build an initializer and call it in the initializer. Load data. Run it again. All right, so there we go. We hit the error. So let's look at this. So it says there is a decoding error, no value associated with key coding key string value ID. So the reason here is it tries to fill the ID in our task because we said it's codable. So it tries to fill all the attributes, but there is no attribute ID in our document. So if you remember a couple of minutes ago, I said that we're going to use the document ID and map it to the ID, and we haven't done that yet. So let's do it now. And in order to do that, we need to import Firestore here as well. So import Firebase Firestore and import Firebase Firestore Swift. And then there is a nice property wrapper that we can use. It's called add document ID. And what it does, it basically tells the Firebase Codable support that whenever we are reading something from Firestore and there is an ID property on a struct that it's, it should read the document ID from Firestore and map it to this field here. All right, so let me fix the compiler error here. There is another problem here. So let's use a compact map. Okay, this looks good. Let's run the application again. And now we receive the data from our backend. Let's go ahead and add a new document here. Again, I let Firebase assign the ID automatically. We've got a title, connect to Firebase, and then another field, completed, is a Boolean, and it's true. Let's save it, and boom, the data shows up in our application on the simulator, which is really nice. All right, so let's see. We are able to listen to the collection to get documents, which is nice. Let's see if we can add new elements. So I'm going to add a new task here. Edit from the UI, hit save, and nothing happens over here. And likewise, if I make a change to any of those elements here, nothing happens. And that's because we haven't hooked up those events to our repository yet. So first of all, let's go ahead and make sure that we can actually add data to our repository, and by that way, transport the data back into Firestore. So to do that, we're going to add a new function here in the repository, let's call it add task, and let's add a parameter for the task. And to add something to Firestore, we can just do this. So db.collection, and then check the collection path. We're going to store it in the tasks collection, and then add document. And again, this is really straightforward. Thanks to the codable support, we can say, let's use this task, and the codable support will automatically be able to map this data into the document. So obviously there might be errors, so we'll need to capture this and wrap this in some error handling. So for now, let's, if things go wrong, we'll just fail hard, unable to encode task, and then let's display the error message, error.localized description. That looks good. And then obviously we'll need to use try to do that. So the result is unused. We're not interested in the result. So let's do let underscore equals to swallow this. And let's run the application again. Let's open the Firebase console, add a new task, add it from the UI, hit enter, and nothing happens. So let's figure out what the problem is. Oh, we actually don't call the add task method. So I should be smarter than that. So what we need to do is call it from here, I guess. So we actually need to call it from the task list view model, because whenever we add a new item to our task list view model, we want to make sure that it goes to the repository and then back into Firestore. So instead of just adding it to our collection, to our internal collection here, we will use the repository to manage that. So task repository dot add task, and then take this task and move it over there. So we can comment out this part of the code, run it again, add a task, hit enter, and we've got 3 elements here. Let's do one more. And it appears here. So you might have noticed that it highlights the added item in the database browser over here. But what you also might have noticed is that instead of appending the new elements at the bottom of the list, it basically appeared to insert them seemingly at random. So this is because when we get the result from a query, and let's go back into the task repository here. So if we get the result from a query, it's going to be sorted in the natural sort order of the document IDs. Which means that it's probably not going to be in the order that you expected it to be. So a very simple way to make sure that all new items appear at the bottom of our list is to add a new field that captures the created time of a new task, and then make sure that we sort by created time. So let's do that. Let's first go into our task and add a new attribute. So let's call it created time. And it's a timestamp. Let's make it optional. And then again, we want to tell Firestore that whenever we tell it to save a task and the created time is not filled, it should use the server timestamp in order to fill the timestamp. Why is that important? Well, the thing is, if we use the client time, the client clock might be out of sync with the general world time or the backend time, and we need to make sure that all data is in sync, uses the same clock, and the only way to do that is to tell Firebase to use the server-side timestamp in order to fill this field. So let's do that. So there is another property wrapper that we can use. It's called server timestamp, and it will do just that. So whenever we save something and the created time is nil, it will automatically fill in the current server timestamp. And then obviously, when we fetch the data, we need to make sure that we sort by created time. So let's go here where we fetch our collection, and then before adding our snapshot listener, we will insert an order statement, and we will sort by created time. All right, let's run this again. Open our console. And then let me see what's wrong here. Okay, let me add a new task. Add it locally. So it's got a timestamp. Let's add another one. Add it later. And it's added here. Let's add a third one. And there you go. So the reason why the other timestamps or the other tasks disappeared was that all the other documents don't yet contain a created time attribute. So the codable support isn't sure how to map that, and it probably fails, and then we don't get those elements back. But all new elements get the created timestamp, so that works fine. Let's do a final one. Great. Cool. So another thing that we need to make sure is when we update any existing task like this one, the update is not reflected in Firebase. So we need to change that. In order to do that, we'll implement yet another method on the repository. So there's going to be a function update task, and it will also take a task, and then we'll need to check if it has an ID. And then get the collection or tasks collection, and then get the document and we want to get the document with the task ID. So we want to go in and get the document, for example, with the task ID of, with the document ID of ZUGD5 and so on and so forth. And this is the ID that we carry around in our task. So task ID, and then we want to override it with data from the current task like this. And obviously this might fail, so we need to use try, and we also need to wrap it using a do catch statement. And if anything goes wrong, we will fail fatally. Unable to encode task. And we will print a localized error description like this. So we also need to call this method from somewhere, but the question is, where do we call it from? So you might recall that we have a task property on our task cell view model. So let me quickly pull this up. So it's here. And we already have a number of pipelines that are subscribed to this property, to the task property. So anytime the task is updated or one of the task fields is updated, one of those pipelines, or actually both pipelines, run. And this is a perfect place for us to also hook in and make sure that when there is an update, that we take this update, push this to our repository, and then send it off to Firestore. So let's do this. So again, let's get our task publisher. And then go ahead and take the update and take the task and then get the repository, which we don't have yet. So we need to subscribe to the repository. So let's do that. Let's get a repository up here. Var task repository equals task repository. Okay, like this. And I think, yeah, we need to make it published. Okay. Okay, so self.task repository, update task, send in this task, and then store the result of that over here. So this pipeline would kick off basically any time that there is a change. So there are two problems. One is if you're making a change and you're typing, then any of your keystrokes will be sent down here. And any of your keystrokes will be sent to the repository. And any of that is going to be sent to Firestore. So if you're making a change and you're typing something there, then we'll have a lot of updates that we're sending to Firestore. We don't want to do that. So we want to make sure that we only send updates once you stop typing. And the way we can easily do that is by using the debounce operator. So we want to debounce for a period of time. Let's say let's debounce for 0.8 seconds. And run this on the run loop, on the main run loop. So we'll wait for 0.8 seconds to make sure that we'll only send updates once you stop typing. Another thing that we need to make sure is that if we make changes to the task ourselves instead of the user making changes, that we don't send those, because that would end up in an endless loop. So what we're going to do is we're going to drop the first update and then only send the following updates. Good. So let's try this as well. Get our Firestore up here, and then so add it from the UI. Let's find one added locally. So this one. So, oops, sorry about that. So whenever I make a change here, so see me typing, I remove stuff, and then only once I stop typing, the update is being sent back to Firestore. Updated and changed. Actually changed, and there you go, there is the update. Also, I can now press the check mark and it will send this state change over to Firestore as well. All right, so our application looks pretty good so far. We can add new tasks, edit them, mark them as done, and everything is nicely synced with Firestore. However, you might have noticed that we're storing all our tasks in the task collection without distinguishing between users. And this means all of our users share the same tasks. Now, I'm pretty sure some people would love the idea of sharing their chores with as many people as possible to minimize their effort. But all joking aside, we need to be able to store tasks per user. So the good news is that Firebase makes this really easy. In fact, Firebase has a full-blown authentication system that makes it possible to authenticate users using a number of authentication methods. So for example, signing in with email and password, phone number authentication, or one of the many so-called federated authentication providers such as Google Sign-in, Facebook Login, Sign-in with Apple, or one of the other providers Firebase supports. One of the most powerful but consistently underrated features is called Firebase Anonymous Authentication, and it allows you to transparently sign in a user without asking them for a password or any other credentials. So how does this work, you ask? Well, it's actually pretty simple. When signing in anonymously, the Firebase SDK requests a unique user ID for the person using the app on the current device. This identifier is then used to represent the user in subsequent API calls. In particular, it can be used to arrange the data in Cloud Firestore so that it becomes easy to tell apart which user the data belongs to. So before we conclude this episode, let's implement anonymous authentication in our application. So there are a couple of things that we need to do in order to use authentication and anonymous authentication. And the first thing we need to do is we need to go back into our Firebase project in the console and go into the authentication section and turn on the authentication methods that we want to use. So go to the sign-in method, and then you will see all the different sign-in methods that Firebase supports. And let's turn on Anonymous Auth here. OK, there we go. Enable it. So that's the first step. The next step is, and we actually did this, you need to add the Firebase Auth pod so you can use the APIs. So we've saved a little bit of time here. And then the next step is to sign in anonymously once your application starts up. And the best place to do that is in your application delegate in the did-finish launching method. So let's go ahead here and then do auth.sign in anonymously. And we're not interested in the completion for now. So that's good. Another thing that we need to do is we need to track who a task belongs to. So if I save a task into Firestore, I need to add my user ID to this task so we can tell it apart from any task that you would add to Firestore. So that means we need to update our task struct right here and add another property. And the user ID basically is just a string. So we can say our user ID is an optional string. And then in the repository, we need to make one change, and that is instead of querying all the tasks, we want to filter and we want to get all the tasks that belong to one specific user. So we can use the where field method and then say, okay, we want to make sure that we only get all the documents where the user ID is equal to the current user. So user ID. But where do we get the user ID from? Well, we can do it right up here. So auth. Oh, we need to import Firebase up here. Import Firebase auth.current user .uid, and then let's assign this to user ID. We're using this down here. Run the application once more. And now we get an error message down here, which says, listen for query at tasks failed. The query requires an index. You can create it here. So why is that a problem? Well, the problem is that we're now querying for a user ID. And in order for Firebase to fulfill its promise that all the queries basically return in in equal time, it needs to have an index so that it can fulfill this query as fast as possible. So let's go and take this URL here, go into the browser, paste it, and it says, I'm going to create a composite index, and here you will see all the fields that are part of the index. So, not only do we have the created time because we told Firebase to order by the created time, but also have the user ID because that's what we filter for. So let's create the index right here, and it will take a couple of moments to build the index. And once that's done, we can run the application again, and it should work without throwing an error at us. All right, so once this index has finished building, we can launch the application again, and it should no longer throw an error at us. So let me go back to the data tab, and actually let's clear the tasks collection here. Okay, so going to start from a blank slate. Build the UI, refresh so we get the data. Okay, so there we are. It's not saving the user, so apparently that is missing somehow. Let's go back and see why that is. So add task. So we need to make sure that we fill the user ID actually. So whenever we add a new element, and we will do this up here in the repository. So we're going to create a helper instance here. And make a copy of our task. And then we can update the user ID and make sure that we use the current user ID to store it here. Okay, so let user ID equals auth.auth.current-user.uid, and then assign this to user ID. And actually we're going to make this a little bit simpler, like this. Okay, so let's give it another try. Okay, let me clear the collection, go into my running application, add a new task, edit, and then of course I need to use this over here. Okay, run again. Build the UI. And there you go. We've got the user ID down here. Add a new user ID. There's another one. And let's add a third one. All right. So to prove that, this actually separates the data of users from each other, let's run the application on another simulator as well to simulate that we've got two different users. So on the right-hand side, we've got the simulator that we've used just now, and now we've got the second simulator running, and you can see the task list currently is empty. And if I add a new task here, add it from the other simulator, you will see it will show up here. And disappear immediately. Let's try again. This is funny. Let's see. Add a third one. Okay, so for some reason it didn't get the current username. But no, it's working. So we can add tasks to any of those applications running on those two simulators. And it will show up in the database, but it will not show up on the other application. That means that we've separated the data per user, which is great. Exactly what we wanted. That's it for today, folks. I hope you enjoyed this quick video about connecting our task list application with Firebase, storing the task data in Firestore, and using Anonymous Auth to make sure users can only see their own data. In the next episode, we're going to look at implementing sign-in with Apple to allow users to use their data on more than just one device. Thanks for watching, and I will see you in the next one.